You know how to make a physicist laugh? Review this article with them. I think this article came out this past year. I don't see a date on it, but I don't know why I'm assuming that. 2019, 2020. Gosh. You're going to love this. The title, What's Making These Things Fly Out of the Frozen Continent? Things are flying out. This is a science article, by the way. Title tells you researchers prepare to launch the Antarctic Impulsive Transient Antenna experiment, which picked up signals of impossibly seeming particles. You mean seemingly impossible particles, as it dangled from the balloon over Antarctica. That's okay. When I type, I talk in notes. I talk in fragments like we all do. I think in fragments. I don't think in complete grammatically correct. So it looks like NASA and myself could use some Grammarly. So here we go. Here we go on this journey. Our best model of particle physics is bursting at the seams as it struggles to contain all the weirdness in the universe. So right away we have thingies flying out of the South Pole, and we have a new scientific term now to describe our universe: weirdness. Now it seems more likely than ever that it might pop. We're talking about the seams now, thanks to a series of strange events in Antarctica. Strange. How strange? That's not going to be strange to you because you follow this channel. The death of this reigning physics paradigm. Oh, the death of physics. You're killing me. Who pronounced physics dead? I want to know who did it. I want a name. But the death of this reigning physics paradigm, the Standard Model, has been predicted for decades. We've predicted the death of the Standard Model paradigm for particle physics ourselves. But it doesn't mean that these high-energy neutrinos flying out of the South Pole have killed the paradigm. What killed the paradigm is the premise that you can make up particles as you go along to explain missing mass and missing energy in your collisions. It's a gluon. It's a God particle. It's a muon. Muon's primary, but it decays. So wait a minute, primary particles don't decay. So yeah, there's a problem with the paradigm. But physics, there's no problem with physics. There are hints of its problems in the physics we already have. Well, if you have a problem with your physics, then it's not physics. Physics will never change. It's only how you apply physics and what you leave out of your equations that can alter physics. Strange results. Again, strange. Why do I go strange? Why do I say that? Strange results from the laboratory experiments suggest flickers of ghostly new species of neutrinos. So already in a science article we have thingies, weirdness, strange, ghostly. A new species of neutrinos beyond the three described in the Standard Model. And the universe seems full of dark matter that no particle in the Standard Model can explain. We explained it. Just because you can't see it doesn't mean it's not there. But recent tantalizing evidence might one day tie those vague strands together. No, not if we rely on you guys to do the stringing. Because all we're doing is getting strung along and not strung together. Pardon the commentary. Now get this. 3 times since 2016, ultra-high energy particles have blasted up through the ice of Antarctica, setting off detectors in the Antarctic Impulsive Transient Antenna and the machine dangling from balloon, but also from IceCube, the actual particle detector that's below the ice. It's buried underneath the ground. Wow. So we read through the article, we see all kinds of references to this and that, but nobody's talking about record high cosmic rays. Nobody's talking about it. Finally, we come across something that has to do with cosmic rays in this article. Many ultra-high energy cosmic neutrinos, many of them, first of all, they're ghostly. They didn't know they exist. When we found them, they're going to blow physics out of the water. But now, look at, many of them occur from interacting with the cosmic rays with the cosmic microwave background. So, get this, the faint afterglow of the Big Bang. It's faint. So get this, cosmic rays are interacting. They're calling it out right here. They're telling you what's happening. Interacting with something. But they want to tell you it's the afterglow of the Big Bang, which is a lower energy, more diffuse source of energy. And this channel has shown you a tenfold increase in the X-ray background alone. X-rays are a lot more energetic than microwaves. Thank you. And they're produced in our own solar system and not from the Big Bang, which happened somewhere. The faint afterglow of the Big Bang. Sure. So you're expecting us to believe that a low energy neutrino becomes a high energy neutrino when it runs into a microwave. But anyways, these high energy things that are ghostly and new and weird, these are called flux, and it's the same all over the sky. Both Anita and IceCube have already measured what cosmic ray neutrinos flux looks like into each of their sensors. But it doesn't produce enough high energy neutrinos that you'd expect to detect a neutrino flying out of the Earth at either detector even once. So get this. Well, I agree with that. I agree that you cannot energize a neutrino or even a helium or a proton with the Big Bang. If you could, we'd have neutrino showers. So describing it as we know, many ultra-high energy neutrinos come from the interaction of cosmic rays with cosmic microwave background. Cosmic rays, the faint afterglow, the Big Bang. This is called flux. It's the same all over the sky. Both Anita and IceCube have already measured the cosmic neutrino flux looks like to each of their sensors, and it just doesn't produce enough high energy neutrinos that you'd expect to detect a neutrino flying out of the Earth at either detector. If the events detected by these detectors belong to this diffuse neutrino component that they say is not so ghostly but's ghostly, should have measured many other events other than just, the neutrinos. They should have measured other particles. But Anita is detecting stuff flying out of the Earth. And so if it came in through the top or somewhere near the top, all right, the cosmic rays of helium, hydrogen, protons, electrons are not going to make it through the Earth. So why are you looking for secondary components to fly out of your ice? And in terms of secondary particles that are the result of collisions, by the way, they forgot to tell you those are at record high levels right now. I mean record as in unprecedented. Unprecedented as in never before seen before. Never be seen before as in mysterious, ghostly, and strange. But in theory, there could have been ultra-high energy neutrino sources beyond the sky-wide flux. Another source. Thank you. They refer to those as neutrino guns or cosmic accelerators. They even talk about one that came from a galaxy once upon a time that they measured a burst of high energy neutrinos coming from a galaxy trillions of light years away. But we look for these events in the 7 years that IceCube data began. But we're talking about since 2016, they've detected 3 or 4 events. Well, that sounds like an annual event to me. And what happens annually? Oh, yeah, we used to go through a focusing cone of accelerated, hot, fast-moving, high-energy, dark cosmic rays called helium ions. No, we'll just leave these pieces out of the puzzle because they're whining about having only a handful of pieces, so we can't put the puzzle together yet. So we're looking for a neutrino gun or a cosmic ray accelerator to produce these upgoing particles, but none turned up. But you're searching for ice cube data for particles to, like helium, to come through the Earth. It ain't going to happen. You got to go to your other detectors, people. Go to your neutron detectors, and there you see your secondary particles. The results don't completely eliminate the possibility of an accelerator source. No, you're right, they don't. But they do severely constrain the range of possibilities, eliminating all of the most plausible scenarios involving cosmic accelerators and many less plausible ones. Well, the one scenario that is possible, the one scenario that is plausible, involving something that accelerates or creates cosmic rays, is a brown dwarf inside our solar system at a northerly position right now. The message we want to convey to the public is not that there's a brown dwarf out there that we cannot see with visible light and that we cannot acknowledge because there's a gag order. It does not work. Our standard model astrophysical explanation does not work no matter how you slice it. Well, no, it does work. You even admitted it. You said this could be explained by neutrino guns or a cosmic ray accelerator in the sky somewhere out there, meaning a galaxy, a star, whatever. Researchers don't know what's next. Well, neither do I. Neither Anita nor IceCube has an ideal detector for the needed follow-up searches. And in this article, they talk about it, how the instrument's ideal for detecting neutrinos, leaving the researchers with very little data on which to base their assumption about these mysterious particles. It's a bit like trying to figure out a picture on a giant jigsaw puzzle from just a handful of pieces. Well, you just left out a couple of your largest pieces. And then there's one last thing, and that is the reflectivity, reflections of neutrinos off of the ice. And when they're looking for secondary particles, they're looking for angles. And I don't know how you determine from the angle of a neutrino, which is not affected by a magnetic field, comparing it to the angle of a secondary particle which carries a charge and therefore is either attracted or pushed away, reflected away from a magnetic field. So you're trying to defer the angles of these particles coming out of the ice by comparing neutral particle with a charged particle. And the charged particles, we know, can't go through the Earth anyway. Whew. You guys, you're wearing me out. Particles detected later at the buried Atlantic Neutrino Observatory IceCube don't match the expected behavior of their standard model particles. Well, they do if there's what? A neutrino gun. The particles look like ultra-high energy neutrinos, but ultra-high energy neutrinos shouldn't be able to pass through the Earth. Well, you didn't even know they existed, so now you're telling us how they're supposed to behave. They're ghostly, they're mysterious, but yet we know everything about them. The ultra-high energy neutrinos shouldn't be able to pass through the Earth. Well, first of all, anything that's ultra-high energy, not high energy, not very high energy, but ultra-high energy neutrinos, shouldn't be able to pass through the Earth. Why? Well, they don't tell you right there, but in the article they do kind of say, well, they're a little bit bigger than the regular neutrino. So if you have something that's just a little bit bigger, but carrying twice the energy, the fact that it can make it all the way through the Earth is plausible. And they told you it is if there was a neutrino gun or an accelerator in the sky somewhere. But ultra-high energy neutrinos shouldn't be able to pass through the Earth. Suggests that some other kind of particle, a ghost particle, one that's never been seen before, is flinging itself into the cold southern sky. And sorry. Now, in a new paper, a team of physicists working on IceCube under the direction and the control and totalitarianism and the coercion of Big Brother have cast heavy doubt on the last remaining standard model explanations for these particles. Except for the most obvious, which is cosmic accelerators, giant neutrino guns, hiding in space. Hiding because why? Because they emit an infrared and you can't see them. It would periodically fire intense neutrino bullets at Earth. A collection of hyperactive neutrino guns somewhere in our northern sky. Did you just fall out of your chair when they said northern sky? A particle accelerator or a neutrino gun in the northern sky, like a brown dwarf, let me suggest to you guys about 40 degrees above the ecliptic, could have blasted enough neutrinos into Earth that we detect particles shooting out of the southern tip of our planet. But the IceCube researchers didn't find any evidence of that collection out there. Well, that's funny. My channel has all kinds of evidence of a neutrino gun, and we almost know exact location today, which suggests new physics must be needed to explain the mysterious particles, because the old physics ain't explaining it. Well, it's never going to explain. Physics cannot change. Physics is physics, and the only thing that can change physics is to change the variables. And if you leave out pieces of the puzzle, or if you change a variable in your physics equation, your math is not going to add up. It doesn't mean that you have to reinvent physics. Give me a break. Oh, I can hear just a whole bunch of physicists clapping right now. To understand why, it's important to know why these mystery particles are so unsettling for the standard model of particle physics. Neutrinos are the faintest particles we know about. They're difficult to detect and nearly massless. They pass through our planet all the time, but just a little wider, and they can't ever. Okay, well let's just put more energy into them. Now, can they? Mostly coming from the sun, and rarely, if ever, colliding with protons, neutrons, and electrons that make up our bodies, and the dirt beneath our feet, and the bedrock even. But ultra-high energy neutrinos from deep space are different from their low-energy cousin. Oh, everything has to come from deep space. Much rarer than lower energy neutrinos, they have wider cross-section. So wait a minute, you didn't even know they existed, but now you're theorizing they have a wider cross-section, and therefore it's impossible to have them go through the Earth. Well, tell me, please, how much wider is the cross-section of something that's almost massless? And if it's just a little wider, because particles should expand as they heat, right? Meaning they're more likely to collide with other particles as they pass through them. Exactly, which is why you only have 3 or 4 bursts ever recorded. The odds of ultra-high energy neutrino making it through the Earth intact are so low. How do you know that you'd never expect to see them happening? Well, how can you be so sure when you didn't even know what the hell this thing was? But now you know it's mass, you know where, but yet you acknowledge it can happen if there's a source, a neutrino gun, or a particle accelerator out there in space. And the sun is the best particle accelerator of all. So from 2016 till today, we would only pass through, depending on the timing, through that helium focusing cone 3 or 4 times. So how many detectors did they? 4? 3? How many? I forgot. So they're coming about once a year, it looks like. But they're not going to tell you that. They're not going to give you that data. They just want to call it mystery and ghostly and strange. In a nutshell, they have these high energy neutrinos coming up through the ice. Could be reflections at an angle. Everything will reflect at an angle. Even gamma radiation can be reflected if it's flat enough angle to a solid object. So we could be seeing reflections, but then you would talk about a flat angle. So, you know, these reflections would be coming off the edge of the ice sheet then. They admitted there's a plausible explanation, a neutrino gun. So I ask you, astronomers that are being coerced and suppressed and manipulated by Big Brother, I ask you, and can a brown dwarf be that neutrino gun? Well, we know already that the helium coming off this brown dwarf comes off at about 10,000 degrees Kelvin. And we know that when it passes through the sun, it gets even hotter and loses all its electrons. So it has to be hotter than 10,000 degrees Kelvin. And so now you have an alpha particle that's traveling 400 to 450 kilometers a second. Not 4.5 kilometers a second, 450 kilometers a second, which is pretty fast. Highly energized and focused in through our magnetosphere. And when you pass through the helium focusing cone, the densest part, the direction of the north flow of electrons into the Earth shepherds, ushers, and creates a flow that directs the alpha particles in towards the North Pole. The ones that collide release a shower of gamma radiation, which is so much higher energy, I mean, gosh, than your microwave background from the Big Bang. And these alpha particles release neutrons, electrons, and subatomic particles known as secondary particles, and of those, neutrinos are the smallest and lightest, but they're neutral. They carry no charge. And all of the cosmic ray detectors on the planet show us that we have what? Record number of cosmic rays. And that the numbers has been rising for years. And guess what? Recently, they have reached an all-time high. An all-time high meaning unprecedented. Unprecedented meaning record. Record high number of secondary particles. So when you have a rising number of secondary particles, and you have a helium focusing cone that we go through once a year, is it any surprise that 3 or 4 times in the last 3 or 4 years that all of a sudden these ultra high neutrinos are released, travel through the Earth directed by the current flow, not through magnetism but through particle pressure, and come out the bottom of the globe. So there you go. Scientists, astronomers are baffled, but you're not. And this is why I always say, this is why the sky don't lie.